Okay, looking at problem number 1 here in 310, it's our first related rate problem. So they're telling us to think about a rectangular bathtub and the base is going to be 18 square feet. They want to know how fast that water level is rising. If water's filling the tub at a rate of 0.7 cubic feet per minute. So they talk about a rectangular bathtub, and what I think they really mean is that they want us to consider that this bathtub is a rectangular prism. So the base of our bathtub, they're telling us, is 18 square feet right there. I would assume they were probably thinking of like a 6x3 bathtub. Those seem like reasonable numbers to me. But the important thing is that the area of that base is going to be 18. And then the bathtub has some height to it. It's going to look something like this. And so water level is filling up there, or water is filling in the bathtub, and that water level is rising over time right here. So this is more or less what we're looking at right here. And the important thing, I think here, guys, is that the area of that base that I'm shading in red right there, and usually we use a capital B in geometry for the area of the base, is going to be 18 square feet. So, trying to attack this like we normally do a related rate problem, there's always one derivative or one rate of change that we were given, and that's right here, 0.7 cubic feet per minute. Cubic feet is a measure of volume, minutes is a measure of time. So this is the derivative of volume with respect to time in the bathtub here is 0.7, and again, cubic feet per minute. That's the only derivative we were given. Then there's always a derivative that we want to know in a problem like this. And so the question they're asking now is, how fast is the water level rising? So we're talking about the height of the water in the bathtub right here, which is a variable quantity as time goes on as we fill this bathtub. So we want the derivative of the height with respect to time. And usually I have to write something at the end of this problem at the moment when maybe the height is equal to this number or time is equal to this number, but they didn't give us anything that specific in this problem. And that's a hint to us all here, guys, that it probably doesn't matter when we're looking at measuring the rate of change of the height here. It's probably going to be the same throughout the entire problem. So the whole key to a related rate problem is that eventually we need an equation that relates dv dt with dh dt. But before we get there, we need an equation that relates just this variable, volume, with this variable here, height. So I'm going to go to a formula that they're expecting that you knew here, guys, that the formula for the volume of any prism, doesn't matter if it's a rectangular prism, a triangular prism, an octagonal prism, it is always capital B, which again I said right here means area of the base multiplied by the height. Area of the base is a two-dimensional measurement, such as 18 square feet. Height is a one-dimensional linear measurement, so that square feet times feet would get you the cubic feet that you're looking for. Now, at first glance, this looks problematic because it's a three-variable problem, v, b, and h, and we only know one derivative and want another. But the key here is that the area of the base of this bathtub is a constant value of 18 square feet. It doesn't matter if there's 1 inch of water in the bathtub or a foot of water or however much there is, the area of that base is going to remain constant at 18. So we could rewrite this now as volume being 18, again, not a time-specific value, that's constant, multiplied by h. And now that we've got that, now I think we're ready to go ahead and take our derivative here. So the derivative of volume with respect to t would equal, well, the derivative of a linear function, like 18h, is always just its coefficient, 18, but because it's implicit differentiation, there's a times dh dt at the end of all that. Now, let's fill in what we know. We know that dv dt is equal to 0.7. So I'll put that over here on the left side is equal to an 18 dh dt. And that means that our answer here to this problem, dh dt, is going to be 0.7 divided by 18, which is certainly not a very nice number here. Whoops, sorry, guys. So let's go to our calculator right here. And what did I just say we were doing? 0.7 and then divided by the 18 right there. And that's going to get us this ugly number of 0.039 if we were rounding to the nearest thousandth. So 0.7 divided by 18 is 0.039. We said. Units right there, real quick, that 0.7 we knew was in cubic feet per minute. The 18 was in square feet. That was the area right here. So what happens? 3 of these feet cancel out with 2 of these feet, and that leaves us an answer that hopefully makes sense. Feet per minute is the rate at which that water level is rising there. So 0.039 is our answer for number 1.